Now let's take a look at process capability index. A process in statistical control does not necessarily meet the design specifications. So we need to, although it's good to look at the statistical process control chart, it's also good to have one number that tells what this process is about. It is meeting our expectation or not, right? That one number, what is it? That's process capability index. This is a measure of the relationship between the natural variation of the process and the design specifications. So although, your process might be under control. However, it does not mean that it is meeting your design specifications. So variance might be small enough. However, it might be out of the design specifications. So that's what we want to look at, whether this process is capable enough. That's the first thing that we need to think of. The second thing is that is this process meeting the design specification? So the first one that I want to introduce you is Process Potential Index. CP refers to potential capability. For example, a student is capable of scoring 95 out of 100. So this is a process potential capability, or CP. And this can be calculated by using this formula. Cp equals upper specification minus lower specification divided by 6 times sigma. So, comparing to the specification, how well your process is performing, and that's what it tells you. And this CP gives you an overall idea about the capability of the product, as I said to you. And second thing is a capable process must have a CP of at least 1.0. So 1.0 means if you convert that to Z value, it's about 3, which is 99.73%. If you also convert that to, product defect per minute, per millions, then 2,700 defects out of 1 million products or services. So that's the CP equals 1 level of the process. Often, a target value of CP is 1.33 for sigma or for Z value, and that's 63 defects per million products, and which is really good. But it does not look at, however, how well the process is centered in the specification range. It does not take the design specification into consideration. It just look at, out of the specification, how well it is performing. So that's what it tells you. Six Sigma quality is Cp equals 2.0. At the time, sigma is 6, and you have only, about 0.002 or, or 3 or 4 defects per million products or services. Now let us look at another one, Process Capability Index. Process Capability Index is called Cpk. It's a statistical tool to measure the ability of a process to produce output within customer specification limits. In simple words, it measures producers' capability to produce a product within customers' tolerance range. Cpk is used to estimate how close you are to a given target and how consistent you are to around your average performance. Cpk gives you the best case scenario for the existing process. It can also estimate future process performance, assuming performance is consistent over time. Here's the formula for Cpk. Minimum of upper specification limit minus x bar over 3 times 3 sigma, and or x minus lower specification limit over 3 sigma. So you choose the lower value of either one. And as I said, it helps you to understand how centered the process is. For example, this one, in this case, it's perfect case, it's 1. Cpk is 1 is perfectly centered, right? So uh, with a specification limit. However, if CPK is negative, then what does that mean? There's only one case when it can be negative. X bar minus lower specification is, or lower specification is less than X double bar, right? So this one is lower than X double bar. That's why it's on the far right here. However, if it is 0, then X bar and this one is the same, then the center line is on the lower specification. If CPK is between 0 and 1, that means it's positive, right? And upper specification is greater than X bar. So here, X bar is right here, but the specification is greater than that, so it's right here. CPK is 1 is perfectly centered. CPK is greater than 1 means this one is very good. So this is far greater than X bar, and therefore the process is in control, and it's aligned perfectly. So usually, if you have 1.33 as your CPK, that's a very good process. Now let's take a look at relationship between Cp and Cpk. Again, Cp is process capability and Cpk is process capability index. Cp gives an overall idea about the capability of the product. Cpk lets us know how centered the process is within the range. Cp is greater than equal to Cpk usually, and Cpk is always lower than Cp usually. And if you look at CP 2.0 and CPK 2.0, that's a very good process. It's centered, and CP is capable, that we can see. CP is 2.0 and CPK is 1.0. Then CPK is centered. However, it's to the right. That's what we see here. And CP is 2 and CPK is 0. Then center line is on the upper control limit. And um, and Cp equals 2.0, so the variance is quite small. Cpk is negative, then it goes out of the specification, yet the variance is very small. So this is, a case that we have to really consider because the process is good. However, the specification is not meeting the process specification you have. So somehow it has to be shifted to the center line.